My name is Sydney Cameron, and I'm going to be reviewing how to solve question part 2A in the equilibrium section of exam 2. So the problem is when 2.24 atmospheres of bromine gas reacts at 395 Kelvin with 2.24 atmospheres of chlorine gas, 0.10 atmospheres of gaseous bromine monochloride is formed. Kc for the reaction is 9.00 times 10 to the third. So since we are given two initial pressures, we're going to be using a Rice table. So you start out by writing the reaction. So we're given bromine gas plus chlorine gas makes bromine monochloride, and to balance the equation, we add a 2 in front of the bromine monochloride. So then we write the initial pressures. So we're given these pressures, it's 2.24 atmospheres for both bromine and chlorine. And since the reaction hasn't happened yet, there's going to be 0 for bromine monochloride. And then the change in pressure, we're subtracting X from bromine and chlorine because they are losing their pressure. And then we're adding 2X for bromine monochloride because there are 2 moles of it. And then the equilibrium part of the Rice table, just adding all these together. So 2.24 minus X for both bromine and chlorine, and then 2X for the BRCl. So then we write our equilibrium expression. So Kp, and then it's the pressures of the reactants over the pressures of the partial pressures of the products over the partial pressures of the reactants. So it's squared for BRCl because there are 2 moles of it, and then just over partial pressure of bromine times chlorine. And then you can plug in what we wrote in the Rice table. So it's 2x squared over 2.24 minus x times 2.24 minus x. And since we are given Kc and the temperature, we can use these to find what Kp is by using this equation. Kc times RT raised to the power of delta N. So then we can plug in what we have. So Kc right here, and then we're using 0.08206 for R since we're dealing with pressures and gases. And then the given temperature, which is 395 Kelvin. And then delta N is the moles of products minus moles of the reactants. So we have 2 moles of the product and 1 plus 1 mole for the reactants. So it's 2 minus 2, which is 0, and anything raised to the 0 power is 1. So Kp is just equal to 9.00 times 10 to the 3. Then we can use this to plug back into our equilibrium expression. And then I simplify the denominator, so then it would be easier to square everything. So after squaring everything in the expression, we get 94.868 equals 2x over 2.24 minus x. And now you're just solving for the x. So you can multiply 94 times 2.24 minus x, which gets 212.51 minus 94.86x, which equals 2x, and then add the x's together, and then divide to isolate x. So after doing all of that, you get x equals 2.19 atmospheres. Now we go back up to our Rice table and look at the equilibrium line. So to find the pressures for bromine and chlorine, you do 2.24 minus x. So we do 2.24 minus x, which we just found, which equals 0.05 atmospheres. And then to find the partial pressure of bromine monochloride, you multiply that by 2. So 2 times 0.05 gets you 0.10 atmospheres, which is what we were trying to prove up here. So in a problem when you're given pressures of the reactants and you're trying to find the partial pressure of the product, you're going to want to make a rice table, and when you're given temperature and Kc, you know you're going to be able to find Kp.